Yes, okay. I'm going to go ahead and kick things off here. So thank you very much for making it to our Bay Area Iceberg Meetup. I want to thank our hosts, AWS, Databricks, PuppyGraph, Snowflake. I think that's the full set. They did a lot of work to get everyone here and organize this and to stream it across the internet. So welcome, everyone. So to get started, just to introduce myself, my name is Dan Weeks. And I am one of the original co-creators of Apache Iceberg at Netflix. And my career has largely followed Iceberg pretty closely. So at Netflix, I ran the big data compute team, where we oversaw all of the compute infrastructure for Netflix and storage infrastructure. And that was a combination of technologies over a span of time, including, Hive, Pig, Spark, Trino, and a number of other projects. And then on the storage side, everything from Parquet to Avro and eventually Iceberg. From there, I left and I co-founded Tabular, where we built out a platform around Iceberg, and I led engineering there. Recently joined Databricks, and within Databricks, I work in the Open Lakehouse team on storage and formats. So to get things started, I thought I'd ask, what is Iceberg? Everybody seemed to have made it here today, so you probably have at least some idea of what that means. But it's kind of evolved from the very beginning, and you may not know exactly how to frame what Iceberg is when talking to other people. If we go to the website, it says Iceberg is a high-performance format for huge analytic tables. And there's kind of a lot packed in there, tables, analytics, format, but I still get a lot of questions about what is this? Why is this necessary? I've got Parquet files in a directory. Like, isn't this fine? Why can't we just, use the file system to represent the data that we want to work with? Why do we need table formats? To understand this, we need to step back a little bit, and maybe a little too far, we'll talk about where this all started. And when I think about this, it all really started around like the early 2000s, mid 2000s, where we kind of got into the situation where distributed systems and data started to intersect. Distributed processing existed before that, data processing existed before that, but this was a time at which there was a rapid growth of a certain set of capabilities, including cheap storage that's really high density, high-speed networking, and commoditized compute that all kind of came together at the same time. And this is where we got the papers around distributed file systems, patterns for doing distributed processing like MapReduce. And at that time, there were a lot of engineers working on this, myself included. And we looked at this as an engineering challenge. Like, we approached this as a question of like, how do we scale? How do we make it faster? How do we make it more efficient? And we did a really good job at that. At the time, like, we were all competing on like word counts and sorting data sets and indexing and Netflix recommendations, all of these kind of challenges. And that's fair. It was a really interesting time. There was a lot of work that was going into this. But the problem that we ran into is that we outgrew our ability to provide guarantees while we were doing that processing. We could process a whole lot of data, but you couldn't necessarily guarantee that it was correct or that it was complete. And at Netflix, we really ran into these challenges because we were building out one of the first cloud-based platforms. And this kind of really put a lot of focus on some of the areas where performance and scalability were challenges in that processing paradigm. So for example, like listing performance is, 100x what it is in HDFS or something like that, at least in the early days of the cloud. Partitioning data and how you structure it was painful because you'd have to rewrite it if you did it wrong. Pruning became a major problem because going and touching lots of files at low latency created a really slow experience for users that were trying to perform ad hoc operations. Metastores didn't scale. That was a point at which like our metadata started becoming big data, and it wasn't something that we could really pull together in a single system and rely on. It just didn't scale. And then there's all the guarantees that we didn't have. Atomic operations, being able to selectively update tables, even like appends or commits. And the cloud kind of made this even harder because the file system concepts that this was built on didn't exist in the cloud at the time. And then lastly, there's like data set consistency. And this is a big problem because you could just like throw files in a directory and now it's magically part of your data set. Or you have a directory that's under there and some engines will process it, some won't. So you'll get inconsistent results. And the worst thing for users was the usability was really poor. Coming from other systems that did analytics, they had lots of strong guarantees and they assumed that they could do those same things here. Schema evolution, having data types that are consistent. Schema on read was a big problem here because it would kind of try its best to interpret the data for you. And you might get different results depending on what you're using to read it. And then the last thing is a lot of the functionality that was available to people was directly reflective of the file formats. You can't reorder columns in a CSV file. Maybe name projection or index-based projection is used by your engine and you'll get different results. So at Netflix, we actually spent a number of years trying to solve these problems, and we approached each one kind of individually. We tried to, parallelize and provide easy restatement of data, re-implement the metastore, and a bunch of the functionality about like file system operations and how things interact with the cloud storage. We tried to improve the guarantees. We created things like the S3 committer to try and atomically, commit data to the data sets. We created complicated protocols within the metastore in order to like swap partitions around and try to provide some semblance of guarantees. We even created consistency trackers that were tracking indexes in our storage system to try and ensure that they actually are consistent. And then the last piece was, from the usability perspective, we just stopped letting users do things. We restricted certain behaviors. Some of them we couldn't, and you just, learn where the sharp edges are, and they kind of develop a sense of learned helplessness. You just don't do things because you're not sure if it's going to be okay. So at that point, we were actually back in around 2017. We were in a situation where we were trying to rebase our platform on a newer version of Spark. I think it was like a major release version. And we were looking at all of these changes that we had made across all of our infrastructure to how we read files, how we handle, operations. And it was really daunting because we knew we had to re-implement this on an entirely new version. A lot of stuff had changed. And we were frustrated because you look at this and we say, this is what my life is going to be like for the next 10 years. I'm going to be rebasing these changes and constantly fighting these problems. And it was at that point that Ryan Blue and I sat down and we were like, well, we can either do this or we can go back and we can say, let's redesign this based on fundamentals. Like we had lots of conversations prior to that about how we would build, tables if we could do that from the ground up. And at that point, we made a pivotal decision to go ahead and move forward with this. It wasn't an easy decision. We got a lot of pushback even from our partner teams because it means a lot of change within the ecosystem and a lot of rethinking about how we solve problems. So we're back to the question, what is Iceberg? So if I were going to talk to people today about what Iceberg is, I'd break it down into kind of 3 different categories. The first thing is specifications. You hear a lot about the Iceberg table spec. It's not the only one. We actually have a REST specification, view specifications, encryption specs, and I think that there may be 1 or 2 others that I can't think of offhand. The specifications really define how we lay out data, and that's the table spec. And once everybody can kind of agree on how we lay out data, anybody can read it. And that's really great. That took us a long way. But then we found that the real problem was getting access to that data. How do you interact with it? How do I look it up? How do I mutate it? And that's where the REST specification came in. And the combination of these 2 things is really powerful because it means that anybody who knows how to speak the protocols and understands how to read and write the specs can touch data wherever it is. You don't need to go load it into systems. You don't need to move it around. It's a really powerful concept. The next category is reference implementations. In order to validate the spec and provide examples of like how to actually do the things that we define in the spec, we have libraries, APIs, and integrations that we provide. This is really helpful because it means that anybody who wants to use these libraries can actually just abstract or rely on them to solve some of the complicated problems that we do in terms of like managing metadata and how do we process the data files. Of course, you can implement the spec directly too. There's nothing wrong with that. But this is an easy way to integrate this into other systems. And then lastly, we have the cloud and storage implementations. These are easy ways to just connect to the common providers, AWS, being able to interact with both the storage and the services in that ecosystem. And the last thing, and probably the most important, is the community. That's how we actually got here. When we talk about community, the largest group is actually our users. There's so many people, all of you, many people out there who are just using Iceberg to solve problems. And that's great. We really value that. We like the feedback from the users. We want them to be part of the community and contribute. The next thing is the contributors. These are the people who are spending their time contributing code, providing reviews, arguing with people both on mailing lists and in syncs and things like that. But we really value that because it results in a better product that solves more people's problems. Then there's a large community of the OSS projects around this. Apache projects, non-Apache projects. We've talked about a few of them. We'll probably talk about a few more. But this larger community is all centered around trying to work together in terms of reading, writing, interpreting, processing, doing the things with data that we need to do to extract value out of it. And the last thing is vendors. Vendors are the ones who actually pay salaries for a lot of us that contribute to these projects. They get value out of it too, but they're a major component of both like the Apache Foundation as well as Iceberg. So talking quickly about the specifications, the specifications are really nice because it brought everybody together in terms of having a consistent language to talk about data. Data types, metadata structure, guarantees that we provide. And then lastly, especially with the REST specification, standards that we're drawing on for other areas of the community for authorization and specifying the actual protocols themselves. The reference implementations have grown quite a bit too. Initially, it was just the Java ecosystem, which is largely, derivative of the Hadoop ecosystem and lots of the tools that existed there. But it's expanded quickly. Like Python is probably nearly getting as complete as Java in terms of being able to interact with the data and metadata. It's great for people who are doing data science and don't want to work with big processing engines or something like that. The Rust and the Go ecosystems are growing very rapidly. So this expansion has been incredible. And we really value all the contributions and the various projects around that. Then there's a wide range of OSS projects. These ones are largely the ones that we have in the actual Iceberg code base that we're working with or we provide connectors to, but there are so many more. I gave a presentation a year or so ago, and I think I had a dozen open source projects, a dozen vendor products, and I missed probably a dozen more. So it's really expanding in terms of just the ecosystem. And the most important thing is a lot of this focus is about interoperability, which is where catalogs, storage integrations, common functionality all comes together. The last thing I'll touch on is community. We are an Apache Software Foundation community, and some of the goals that we have are really to be neutral and inclusive. We've got lots of people of different backgrounds, different companies, all contributing and working together. We want people to be open and transparent. Share your challenges, why you want to make changes, come to the community with good intent. And the last thing, and particularly with the Iceberg project, is we lean very heavily into discussion and consensus. We don't like to move forward unless everybody is in agreement, or at least willing to move forward. That doesn't mean that we don't argue. We argue a ton. There's a running joke about me and Ryan arguing. So that isn't necessarily a bad thing. We think it results in better outcomes, but the reality is we want the entire community to be working together and moving forward together. So where are we now? Well, the current state is, if we're looking at the actual table specification, the version 1 and version 2 are actually pretty well adopted. We've got multiple language support. We've got a lot of engines that know how to use the vast majority of the capabilities in those areas. You can see the list of things. You're probably familiar with many of these. The V3 format is something that's been ongoing for a while now, and it's quickly coming to convergence. A lot of the things that we want to include in V3 are really coming together. Many of the specifications have been drawn up and are in some process of being adopted or in review. And lastly, the implementations are going out. Many of them, deletion vectors, there's a talk later on about that. We already have the implementations in, so we're working on formalizing those. So what's in V3? V3 includes a number of exciting things. Like first of all, data types. Variant data type for all those people who like semi-structured or slightly unstructured data, especially JSON. This is so much better. It also includes like shredding, optimizations that engines can perform to be super fast. The geotypes, we're working with the Parquet or GeoParquet community and Parquet community to settle on those. Timestamp nanos and unknown, throw it in there because we didn't have it. You know, all of these are actually community efforts. There's a lot of collaboration that's going on between the Parquet community, the Delta community, the Spark community, many of these other communities that have actually built out these data types. And a big part of this is making sure that we have consistency in terms of how we represent data, because the last thing anybody wants to do is go and restate a bunch of data just because you had a small type incompatibility. The next thing is improved deletes. There's a big talk on it. I highly recommend you listen to it. But it is about improvements that we've made over the previous positional deletes, how we represent them, how we track them. You know, a lot of improvement there that we think will really help with, you know, merge and selective delete capabilities. The last thing is row lineage. You know, adding row lineage allows for, you know, doing row tracking, incremental processing, and, you know, there's a lot of patterns around CDC and things like that that can build off of this functionality. So on the REST spec side, there's been a large amount of adoption over the course of the last 6 months to a year. A lot of people are coming out and they're recognizing that this is a great way to make data accessible, to standardize on how you interact with data. It doesn't mean necessarily that it's optimized or anything like that. There's always space for that in tools, and we want to encourage that, but being able to access data and mutate it in a standard way is incredibly useful. So these capabilities have largely been adopted. There are many providers out there, both vendors and OSS projects implementing these capabilities. And what we're looking right now is how do we improve this? A good example is, you know, server-side scan planning, pushing some of that complexity of working with the Iceberg metadata back to a catalog or service. This really helps the client because it needs to be less complicated. And there are a lot of situations where you really just need to know, like, which files do I need to process, you know, instead of the fine-grained details of like how to work with the metadata. Fine-grained commits is the other side of that. If you need to be able to append to a table or add data with all the guarantees, but without all the complexity, that brings that to the table. And then we have been tracking multi-table transactions for a really long time. I'm really excited about this, and I think we're starting to get to a point where some of the technologies around this and, you know, the kind of guarantees that we want to specify for these behaviors are getting to a point that we can actually round this out. And then there's like optimizations like freshness checking, things that will help engines in order to better perform against a REST catalog. So then where are we going? I would say that, you know, Iceberg is a community, so nobody can specifically say what the roadmap is, but there are a lot of things that are going on. And I would say the way that I would talk about it is to kind of distill what kind of problems are we seeing from the community? What are people running into? You may have run into some of these. So one is around like scalability and performance, the metadata size. There are lots of things that you can do that will actually blow up your metadata in bad ways. And we want to make sure that there are easy ways to like curtail the size of the metadata, make that really efficient, and make sure that, you know, it's performant for the use cases. The next thing is scan planning. We want to improve scan planning. There is definitely a lot of overhead in that. And when you get to really large data sets, that can easily become a problem. Fast commits. We've seen, especially in streaming cases, that people want to commit to tables really, really fast, on the order of seconds. And this, you know, exacerbates some of the problems around like metadata size and scan planning. And we want to start looking at ways to solve those problems. And finally, catalog optimizations. There's lots of things that we can do to make those better. The guarantees that we want to bring, we ran into actually as we were working on the V3 spec, you know, being able to do type widening. There are certain limitations that we have in the metadata structure that actually make that quite hard. And we had initially planned to do some work in that area, but the nuances and some of the checks that we have to do and the uncertainty about how we would actually like represent that was enough to kind of push that back and say, hey, we actually need a more fundamental rethink of that area to make sure that we can provide strong guarantees there. Partition stats is something that's been worked on as well. Again, optimizations, improve query performance. And then there's a wide range of maintenance types of activities because, a big part of Iceberg is deferring work. We want to be able to make commits, reads as fast as possible, but there is a maintenance component. And what people run into frequently is cases where something has been deleted because of either like bucket retention or something else, and they need to be able to restore tables to a healthy state. There are also cases where you can actually recover data in safe ways. And then finally, more advanced metadata management for things that are, ready to be removed from the table and is just like accumulating over time. Next thing I would say is actually a challenge around scaling the community. We started off as a very small project and we've grown very rapidly. And in order to have a really healthy community, we need to make sure that we are communicating well, we are talking with others, we are helping other people solve problems, and we're collaborating with good intent. And this is something that we've actually seen a lot of successful activity on, especially in Slack. It was originally just a few people trying to answer everybody's questions, but now you go in and you see people talking to each other, how they solved problems. It's really become an incredible community. Okay, well, how do you get involved? It's an Apache project, and there are kind of standard ways to engage with the Apache project. One, of course, is like we do a lot of collaboration on Slack. So if you're just like asking a question, you want pointers to something, Slack is a great resource. I think we maybe are over 7,000.
Just checking. 6976.
6976. Go join Slack. Push us over. Push us over the fact check right there. The next is the dev list. This is where all the real work gets done. Anything official needs to happen through the dev list. This is where we do votes, where we do discussions, participate. It's a great thing to sign up for because you actually just get a nice little thread of what's going on in the community. And then the last thing is contributing. GitHub, you can open pull requests, add docs, create issues. We love to operate through that mechanism, and we actually watch that carefully. Lots of people are looking at it, issues that are coming in. So please join the community, join us. Thank you. I don't know if we're taking questions.
Thank you, Daniel. Really appreciate it. Open for questions. We do have some time. Very hard to get Daniel sometimes, so I think this is a great opportunity. I really want to thank you. The more I hear, the more and even today, we haven't even scratched the surface. This is how, this looks so beautiful problem. And it's not us coming in and saying that when we work with customers, real world problems out there. And variant data you talked about, these are problems that are real world problems. And I think what you started out, and that's becomes where the community has really contributed to this. So really thank you to everybody, first of all. Thank you. Please, let's take questions.
I think we have one over here.
It would be great without question.
Hey, thanks, Dan. Really inspiring talk, and really glad to see you. So I found it interesting you mentioned about how in Netflix, you initially were having other solutions, then you decided to start over from the fundamentals. But I'm wondering what helped the most for you to convince all the stakeholders and the leaders in the company to take such drastic change?
We got some stakeholders right here that could probably answer. But it was definitely like some of the earliest use cases were the people that had the most pain, right? Whether it was a scalability challenge, they had huge data sets that they weren't able to work with. Their users weren't able to actually query that data. For example, there's one that's one data set that's like a telemetry data set of like all the metrics that Netflix collects for everything. And they were very limited. The data scientists were very limited in how much data they could actually consume. And a lot of that really had to do with one of the problems of just like how you partition the data and how selective the actual planning process is. And the listing performance and trying to just enumerate which files need to be touched and touch them just to find out that you don't even need to process it, that could take 15, 20 minutes. There were cases where it wouldn't even complete that process and they just had to start over with smaller data ranges. And Iceberg actually brought that down significantly. We did some early talks on this. I think it got it down to just like minutes, like single digit minutes to process across multi-petabyte warehouses or data sets, single tables. So we attacked the people with the pain first, and they were willing participants. But then there's, of course, like this long tail, and that's a challenging problem because you go to people and you say, hey, I want you to switch over to this new format. And they say, I get the same result. Like, I'm not doing anything. I haven't touched it in 2 years. Why would I change? And so it's really about making sure that you provide enough of a carrot, like the functionality, the capability, and they see the value in moving over. So it took a long time. It took many, many years to convert the warehouse over to Iceberg.
Yeah, thank you so much. And I saw that when you were sharing version 3 specification, and there was an update on timestamp, right? My question is that will this timestamp will include time zone information in it, or it will be without time zone?
So it's both timestamp with time zone and timestamp without. They're all represented as UTC. So the one thing that you need to know about the timestamp, and it has been a little contentious, is like we're actually storing it as 64-bit. So that really limits the range of dates that you can use. And this is kind of a reasonable trade-off that we're trying to make between like where you actually need nanosecond. You know, if you're doing geological events back in, you know, however many thousands of years ago, you probably don't need nanosecond precision. So it's kind of a compromise in terms of like how we can represent it versus what the utility is of a timestamp nano.
Okay, because just a small follow-up question, because current version of timestamp with 6 nanosecond, like microseconds, is only with either local time zone or no time zone. It does not include the actual time zone. Is that correct understanding?
Yeah, you don't store the actual time zone with the data.
I just have one question. This is about the REST catalog. I didn't see anything in the community things that you listed out. Is it pushed for V4 or what is the?
Oh, I did have a slide. It was not, there's no like specific version of the REST catalog. It's actually just kind of like a continuously moving specification. We try and make sure that it's both forward and back, or well, at least backward compatible. So there were a number of enhancements that I did list for the REST specification, but it's not like a strict version increment. So we'll kind of like add those incrementally.
Yes.
Hey, so when you talked about fine-grained commits in the future, so how fine-grained will this commit be? Like, will they be like record level fine-grained or what?
It's still an early discussion. I think the most obvious things are appends, right? Because there are a lot of systems that may be able to like produce files and want to quickly append that to a table. And they may not have the logic to perform the commit, or they may actually want to defer the commit. So if you're just like streaming files super fast, you may actually want to accumulate them up for some amount of time before you actually perform a commit. So these are all just different ideas that have been thrown out. Nothing has actually been settled for the fine-grained.
So is it mostly driven by streaming ingestion, the fine-grained commits?
I think it's a combination of streaming and trying to incorporate clients that don't have as much integration with Iceberg, that don't understand the full metadata or don't want to be able to produce the full metadata. But streaming is a major component in that.
My question is on the V3 spec. Is there a timeline when it will be out? And second follow-up is, which topics in the V3 spec are already agreed upon in the community and which are still being debated?
So there are a number of things that have already been agreed upon and voted on. They've been introduced in the actual spec, so you can go read those, and they're annotated as being part of V3. When it'll actually close is really up to the community. You know, there's a drive to complete some of the work that's already been defined for V3. And then, you know, of course, we need to go through the process of actually voting on those things and making sure that we have proper reference implementations. I think right now, Parquet has the variant spec that we're leveraging from Iceberg, and that isn't fully finalized in Parquet. So we're kind of working with them to finalize the specification in Parquet, get reference implementations out so that Parquet can close on that implementation, and then Iceberg will be able to close on the actual Iceberg variant implementation. We're working with those
I have one
communities.
question.
Yeah.
So now that LLMs can search and summarize data from various sources, how will Iceberg make things easier for LLMs? Do you have any kind of reference implementation around that?
I do not. I work on storage and table formats, which are very important to AI, but I am definitely not an expert in AI. So I couldn't hazard to guess what that would be.
We have time for one more question.
One more here. CDC. When we're gonna have a standard Iceberg CDC?
That's a good question.
Of course.
Like, I mean, I think that there are a lot of primitives that are coming, like the row lineage is an important one, the incremental scans, things like that. And, there's work that's being done to help in like Spark, introduce interfaces for DSV2 to help abstract some of those things and standardize at least the implementation on that side. But I think that there's still a lot of work going on in CDC. It's still kind of coalescing. So
not in V3, right?
not something specifically CDC that I'm aware of. I haven't heard anything. Like some of the constructs that you'll need to build good implementations on top of it will be part of that, like row lineage.
Thank you.
Okay. I think we're out of time, but you can catch me afterward.
Yeah.
I'll be hanging around.
I would request, because we are about 15 minutes behind, what I would, if you're around, please, if we can also ask a few questions to you, maybe outside or maybe, that would be awesome. But I really appreciate it. Thank you, Danny.
Thank you. Thank you, everyone.